Good morning and welcome back again. As usual, we are going to talk about new chapter. It's called partial derivative. And before we start, you can see from here we have a function of several derivative or variables. Sorry. So partial derivative is the main title, and you have a subtitle, was called several function. You know, before we saw in calculus 1 or cal 2, for example, we have f of x we say that f of x is equal to x squared. Now, today we have f of x and y equal to x squared plus y squared, something like that. So the first one is single variable, and the second is double variable or several variables. Sometimes your function will contain f, x, y, z. For example, you have x squared, y squared, x, z. Okay, dear? So it depends on the situation that we have. This is about chapter 14, and we are going to talk about equality, domain, derivative, and whatever we have. So in the first function, as we say, sometimes we can represent it as y equal to x squared. In the second type, we say z equal to x squared plus y squared. In the third one, we say w equal to x squared y squared plus xz. Is that clear? Because when I say partial f of partial x, sometimes we say partial w of partial x. Both of them, they have the same meaning. Is that clear? Good. Now, we are going to talk about simple things. For example, if your function is x squared, y squared, z squared, we start with the town, you know, x is called independent variable, y is called dependent variable. In the calculus 1, when you have f of x is equal to x squared, you have x squared. When we say domain, we mean this one that we can input the function. For example, we can give the all real number to here. When we say range, we mean the output. This is input. For example, if you have a factorial like x squared, input is x axis, input is domain, input is independent, and output, of course, we have output is range, is y-axis, the graph or the y-axis is the range, is the output, is the dependent. So based on all this information that we collected from high school to first class in the calculus 1, then we can decide here's the same. We have the same input, output, domain, range. All these concepts are familiar for you, right? You heard about it before, and you, of course, you solved many examples on it. Now, let me start with a simple example. We have xy, for example. If I say is equal to x squared minus xy. If I say find 1 and 2, you know how to do it, right? So it means that x is 1, y is 2. So you see in that case, you see 1 square, 1 multiply 2, and you'll get, for example, 3. Clear. The same thing is true for 3 variables, 4 variables, n variables, several variables. If you put any numbers, you'll get the same. For example, here we have F304. Instead of each x, I'm going to put 3 and y0. The last one, z is what? Z is 4. Is that clear, dears? Good. Now, we are going to talk about domain and range. The domain and range here, the same strategy that you use it in the... Actually, range is not more accurate, or we cannot concentrate on it because the 3-dimension, it's not easy to find all range, but the simple one is clear. For example, look at the first example that we have. We have what? We have x squared, z equal to y minus x squared. First example, z equal to y minus x squared. In calculus 1, when we have f of x or y equal to x, we say that the domain is x greater than or equal to 0, because under the square root, there is no chance to have negative, right? The same thing is true for here. You can say, that's why I say easy, even you can say is x squared. Okay? So what do you mean? Means that under the square root again shouldn't be negative. Am I right? Should be greater or equal to 0. So that's why sometimes you can play with it like that. Both of them are the same. Understood? So this is your answer. That's why you have something like that here. Is that clear? And you know, never the output of square root in calculus 1, you'll get 0 or positive. Am I right? If you remember, you say the graph it was like that. Here's from 0 to infinite, the domain, and range here, again from 0 to infinite. Am I right? Never, you will never get the negative output in square root. That's why the same thing is true for here. When you have z equal to y minus the x squared or whatever you have, we say the domain is what? Is y greater than or equal to x. How about range? We say 0 to infinite. Look at here, even in calculus 1, when you have a function, here's number, is output last number, one result. Means that one variable give you the, for example, say y equal to 2, 3, 4, 5, like that. Here is many. Here you say x greater than or equal. Here you see y equal to from 0 to infinite. What do you mean by that? Look at here. In the domain is the value or relation between x and y. How about range? Is the output, is just the value of z. So when you say from 0 to infinity, means that z can be counted from 0 to infinity. You got it? Only z. But when we talk about domain is about what? Y greater than or equal to x squared. There's a relation between y and x. Is that clear? Yes. You didn't get it? In 3 dimensions. Can you close the door, please? Thank you. In 3 dimensions, okay, when you have table of domain and range, thank you, here is only value of z. Here is the relation between x and y. For example, you say y greater than or equal to x squared. You got it? There's a relation. How about here? You say from 0 to infinity. You have a number. I mean that. Even if you want to represent in the 3 dimensions, when you say domain, you say relation between here, maybe minus here, here y, here's x, you know, maybe minus x, am I right? Okay, but you say y greater than or equal to x squared. But when it's time to sketch or to just represent, you say what? From 0 to infinite. What do you mean? I mean y-axis. From 0 to infinite. Clear? So relation with x and y will give you the domain, and the output of z will give you the same. The same thing is happen for the next example. We have y, z equal to 1 over xy. We know if I'm going back to what? Going back to calculus 1. If I have something like that, I say what? Kaka. Domain of the function r without 0, right? How about the range of the function? The same, right? R without 0. So this one is true for z. That one needs something else, relation. So we say what? Because I have x, y, I say x, y not be 0. Am I right? What do you mean? It means that x not be 0 or y not be 0 or both. Right? X multiply y not be 0. Yani 0, 0 is not in the domain of this function, z. And 0 and y, what do you mean by 0 and y? Yani y be anything. Right? Shouldn't be in the domain. And what else? X and 0 means that all x with 0 shouldn't be in the domain. So when you want to summarize all this one, you say x multiply not be 0 because we contain all 3 cases. Am I right? Clear? So that's why I say this is the relation Domain is the relation. How about Z is number, one output? We say what? We say the range of this function, range of the function is from 0 to infinity. Am I right? Am I right? No, I'm not right. All real number without 0. All real number without 0. Clear? Hello? Good morning. Good. So all real number without 0 means that 0 to infinity, 0 to minus infinity, excluded union. Look at here. Sine. Go back when you have sine of xy. Go back to what? To calculus 1. Z is equal to sine of x, or y equal to. You know, sine was the continuous function. The domain over x-axis was all real number. Am I right? How about the range? Between 1 and minus. That was clear for you. The same thing is true for here. I say z equal to sine xy. So the domain of here is what? You can input all x and y. Am I right? Hello? All x be in R, all y be in R. This is all. Means that all. Okay. So if I have all x and I have all y, means that what? Means that xy plane. Am I right? Entire plane. What do you mean by entire plane? We mean by xy plane. You know what I mean. So you can input every number, but generally you need to answer. You don't say x be 1 and y be 2. No, generally, yes, all real numbers. How about y-axis? All. So totally, or general formula that you want to answer, you say xy plane or entire plane. You got it here? You have exercise like that, so carefully do it. How about range? We say that. Range of signs between what? That's same. Clear. You need a little bit review, not deeply, just review it. Just read it 2 times. Calculus 1, domain and range, chapter 1. So I recommend you to get more information, review. Now we have a video and we have many things. Review Cal 1, chapter 1, domain and range, especially for domain. Easy, dears? Hello? Okay. How about that one? It's 3 variables, right? The same strategy. We are going to use the same here, but here, domain is the relation between x, y, and z, because I have 3 variables. Independent are what? X, Y, Z. A dependent is what? W. So here W will be the single value. Understood? Here's the relation, here's the single value. Okay. So tell me about this one. I forget, right? For example, I say f of x is equal to x squared. So in that case, domain of this function is what? I can put negative, right? Because I have x squared. Positive. Good. So how about x squared plus y squared? No. R for 1 variable. For 2 variables, we have something else. Entire plane. We have R here and R there. Am I right? So entire plane. How about that one? Because 3 of them are square and between them are addition. You will never get negative, right? So 3 of them is true. The same thing is here, the same thing. So here, I say what? I have R for x, right? And R for y. Am I right? And R for what? For z as well. So it's called what? Entire space. Entire space. That's from all, right? So that's why in the domain, instead of entire plane, we have a space because 3 dimension. How about output? We say that output of anything it will be between 0 and infinity. You'll never get negative. Clear? So look at here. Here's the relation between x, y, and z. Here's the only output that we have. X square, y square, z square. We see that we have where's the problem? The denominator shouldn't be equal to 0, right? Then we will get a problem. We say x not be 0 means that x not be 0. X axis all but make a gap. Clear? But how about here? If x is 0, we get problem alone? No. Uh-oh. If y is 0, I will get a problem. If x and y is 0, I will get problem. How about 3 of them? Only one case will make denominator 0. For this w, only one case we have. In that case, right? 3 of them at the same time to be 0 means that all space except origin. Am I right? Because 0, 0, 1 can be included. How about 1, 0, 1? Again include. How about 0, 1, 0? Also accepted. Just only 0, 0, 0. You didn't get it? You get it, dear? Good. Because only that case I will get 0, 0, 0 is equal to 1 or 0 was undefined. Otherwise, all these points can be included. Just only origin. We see the entire space without 0, 0, 0. You can say entire space without 0, 0, 0. Or you can say x, y, z not be 0, 0, 0. Otherwise, all accepted. How about the range of How about the range? Think about it. That one, the range is what? Am I right? But if I make a x square, I'll get what? Positive, right? From 0 to infinity, right? Change it. Why? Because the square never let you get the negative fraction. How about if I add another thing? The same. So here will be 0 to infinite. Why? Because we know that z here is all positive and square. So positive square, positive, positive square, square. So I will get never negative. And of course not 0. So means that from 0 to infinite. Clear for the first one, the third one, or second one, sorry. Shall I leave the third one? Shall I leave the third one? Can you explain? Yeah? No. So shall I leave it or not? Leave it because it's hard? Okay. So, I will remember you that y equal to ln of x. What was the domain of this function? Yes? Okay. So the graph it was like that, right? We say the domain is from here to there. So it means that domain of this function from 0 to infinite. Clear? Hello? How about range? Huh? Same? No. All real numbers. All real numbers. Right? Hello? Good. The same thing is true for here. We have what? We have x, y, a, ln of z. X is polynomial. Domain is R. Y polynomial. Domain is R. R multiply R, again R. So you'll get a plane for these two. Am I right? How about Z, the third part? We see the relation between X, Y, and Z because we have three variables. So how about Z? Only greater than 0. Clear, just only Z. So I have what? I have plane and only from here to up. So we have what? Half space. Why half? Because we know space is Z, negative, positive, 0 with X and Y. Right now I have X and Y, or entire plane, then Z up from 0 to up. So I have what? I have half space. And which one? Which part half space? Down part or up part? Here to up or here to down? Here to up. How? By Z greater than 0. Understood? How about range? The same. Range of here R, range of here R, range of here R. So by result, I'll get what? R. Clear? That's why I say review. You need to review E, ln, just simple things. Square root, absolute value, just simple. Just look at them, think about domain and range. Sine, cosine. It's not hard for you, of course. Yes. أخذ بري أمام آية. سه variable میوانیه. کشل ما هي. أمام همون real number. وانية. أو كشيت يعني. أي كشل ما هي. أمام أوش همون real number. أي كشل ما هي. أبي لك شو أبي وكشكي. أبي زيت شو قيمتي. نه الرسم نه تو بس کالکولاسیه گو رسمه کی نظم رسمی واسه درس 3 dimensional understood جای بس بیل لكم so clear now I have what Z is the problem because Z shouldn't be negative or 0 that's why I say chi I say I'm a plane كم كشينية على ركشة here we have a problem here نابي 0 بيه نجبر نيجاتيف بي am I right كاتي delete يكين cancel يكين چی کرد وقت من half space كم halfي positive أكيد مش كأما جاء أما جاء half negative أكيد بلام كم يعني on z greater than 0 ولا برا اللي برا output اللي نوعه ln of z اما x y وانيا x بايك ب y باي 2 ب باشا حزكي لني زياده كبا 1 over 2 ب يكسر دره نيجاتيف درجه بو دبروي نيجاتيف هب شو كالكولاسيك باتد جينم اما 0 وانيا علي ln of 1 0 وات 0 بالانس Leg greater than 1 will give you positive output. Positive output. Kawata 1.1 is 0. 1.1, 1.001 will give you positive. Say y axis ka. هم باشه رسمه قال لك upper وانيا. كاتا ليرة positive تياتي. لني دا positive تياتي. نظام شو نظام positive. بلام after 1 رسمه قالته تخواره. يعني 0.999 negative value اوكي negative يا باشا من 0.5 مايتي تو negative دسكو so output w negativity يا yes وني وني output w شارك negative دسكو yes everything اما رنجا negative يان او كرت بيه You got it? Good. أي صفريتيا. Yes, maybe this one be 0. باك 0 بعدين كهمي. So 0 شمال نسكو. أي positivity. You get the possibility? Yes. هم مشتاق? Yes. Any numbers? Yes. كات علم شيء. يعني output بمعنى يعني بس single value كه. هي شيء W. نمو to output Z. نمو to output دي علم generally W. W yes. أما جاري من دواي اللي متباسكين. Okay, in your exercise, sometimes you say what? Describe the domain of the function. You have what? F of x and y equal to y minus x squared. You say what? Describe. When I say describe, means that put it in cal1. Bring it back to single variable. What do you mean? Then you know. We say the domain. Am I right? We talk about that one. So, give me the sketch, the graph of y equal to x squared. How is it? Parabola, right? Parabola, am I right? Hello. This is y equal to x squared. Is that clear? Yani here. Just this curve, boundary. How about greater than? Is here or there? Y greater than x squared. Where? Agar equal be. So area greater ya بسكتر. Area greater ya بسكتر. Which part? Now, why? You're right, but why? Why? Yes, you are right. Good analyze. Good description. Another idea? يعني era آخر why, you see why. For example, let your classmate understood. Y is not here. Why I'm not? For example, I'm going to sketch it. Why I'm not sketching here? I should sketch here. Why? I need to fill there. Why? Put numbers. At least put numbers. For example, put x be 1. Y will be what? Hello? 1. Am I right? Good. How about if x is 2? Y will be what? So 4 is where? Understood? Hello? How about the same? So here will be, how about if x is equal 0.5, 1.5, sorry. I'll get what? 3 point something, right? So here we are, that's why. Good. And we are going to fill the gap here. Why we should fill it? Because we say y is greater than or equal to x squared. How about here? Y is less than x squared. Here's greater than square. So I have a parabola. Listen, Kaka. I have parabola. Y equal to x squared is the red one. Y equal less than x squared is the black one. Outside. Y is greater than x squared is the blue one. You got it? You don't get it? Okay. I have ball, circle, ball, whatever you see. I have 3 cases. Boundary, cover key, circumstance key, chair key. Ya now, way under way. Clear? Circle كم هي؟ وبس بتيجيشن. أما يعني شيء يعني only Edge-ەکەم باس کرد circumference-ەکەم باس کرد تەنها چێوەکەی you got it okay now ئەگەر بڵێم ئەمە چۆ وەگرێتەوە you mean what where now وەنیە ئێگە بڵێم دەرەوە وەنیە ئەوە چۆن تعبیرەکەم ئەڵێم x square y square greater than 1 وەنیە لێک بە دەرەوە کەواتە ئەگەر بە تۆ بڵێم x square y square less than or equal to 1 تۆ کێ ئەڵی ئەڵێ ئەم دوانەیە وەنیە هەڵۆ ئەڵێ بەرگەکەی و ناوەکەی هەمان قسەم کرد بۆ پارابۆلایەک ئەم خەتە کوێیە y equal to x square ناوە کوێیە y greater than x square دەرەوە کوێیە y less than x square clear ئەم ژوورە جوانیە ئەوێ بە سێ بەشەوە ناوە دیوارەکان دەرەوە it's called interior boundaries exterior تاوانی so how do you describe them for example I say x square inside x square edge or boundaries less than is outside you got it so this is sometimes described and you have exercise so try to make the equality and then solve it we have a level curve of two variables also that one will help you to define the domain look at here Kakija. First of all read the definition you will make your function I don't say memorize I say read and understand you have f of xy with z you say equal to c you make it constant you fix it as I was fix it now نظر فيكسي دانا ويانا فيكسي كان كاش معناه اوكي او سيرفيسي داس معنا كمبيوتر كمبيوتر ليفل كيرفز اوكي تناغم بابشين سر example again let us go to the example look at here f of xy equal to 100 sorry equal to 100 a what else minus x square y square clear I say what I say let's find or in your exercise find level curve I say 100 minus x square minus y square equal to c. Any numbers. For example, let in your mind be 0. Okay? C is the constant. Okay. So I'll get what? X square plus y square equal to 100. Am I right? Which mean what? Huh? Sorry? Circle, you are right. Circle, okay. Circle with what? Am I right? Center 0, 0 with the radius is 10. What did we do? Just we gave number to function and we got a curve level. How about if I put this number? How about if I put this number to be instead of 0? We say C1, C2, B25 or 75. I'll get what? Right? For example, and I will get what? So, another level curve. How about if I put 100, CB 100? I'll get what? 0. 1, 2, 3, 400, 200. Am I right? 500. I don't know. Did you understand? What did I do? I changed the function f of x, y, 100 minus x squared minus y squared to be fixed as a constant. Then later on, I play with the constant to get the imaginary or to get the image of what in my mind. Then I got a circle, circle, circle. This level is called level of curve and has got many applications in real life. Understood? Hello? Just make a function to be some constant and you'll get the shape. Maybe square, maybe circle, I don't know. You saw that one. When you are a kids in the primary school, you have a what's it called? Glasses. Water glass. You make it like that. You remember? It was like that and like that. So generally you have what? 3 dimension. Am I right? You are in the 3 dimension. Then you make it what? 2 dimensions. پرداخەکانتان بیرە بە مناڵی هەموومان شتێکمان هەر بینیوە ینی پەرداخە کاسیرەکەی قەپاقێکی ئاوە هەیە ئۆکەی دێن ئەمە ئاویشی تێکەی ناڕژێ وایە دوایی کە ئاوای لێکەی ئەبە ماڵین لیڤڵ کەرف لیڤڵ 3 dimensionێکی دروست کردو چی لێکەین کەرتێکین ئەخێنە سەرێک پیشانێن کە چییە ka circle. So level curve is what? Make your 3 dimension, fix it in one side. Understood? Zaman esta au garbage au bina level curve. Yakam jar circle ka gadi khati waniya. Awase ki 3 dimension bas ka aile ki hami circle درست بو parça خاطر سریع. So easy. Our level curve. Did you understand? Or describe yaki. So how to describe like that? Look, 49, 25, and you make a level. Then you'll get what? You will get the circle. Is that clear, dears? Did you understand? Yes, Kaka. Harraga adam describe it. Find the level curve. I been yesali exercise agap shanti. How about level surface? The same. لو چی معنی بو z equal to c وانه بو یعنی z f of x and y equal to number. How about here? هم داره w اکین باشته. For example, look at this example. X square let that one be 0. Why 0? Easiest one, right? I'll get what? Equal to? So çim desek here? Okay. Let be that one. W that time be 5. I'll get what? Our cheer. Equation of what? Surface. Surface? Sphere. Go. Sphere. One year? Good. Top. Ball. Why? كاتبوا بشي pointer ball bigger than one basketball and football like that. So چیم دست کاس؟ یعنی اگه describe کنم چیه؟ Level surface again چیه؟ Is sphere. ونیه؟ Contain وایانه. Contain origin and everything. اوش بخوانو تبقى. سير رسمك ایکه. When 0, 0, when 1 only, when 2, 3, 4, 5, and top of this, okay, you'll get the ball. Do you get it? Dears? Did you get it? چند حال level کی وارگی زاین چی درستو؟ ساما level وارگرم what is square ونیا؟ level درست باتو دستراز square. 3 dimension yes. چون درست با level square like that. For example, as you ask me, I say I'm gonna show you. Domain, range, level curve. Okay, boundary is not included. Open range وأنا قينا decide domain bounded or unbounded وأنا غزلي بينهم. So these three are important. A, B, C are important. Understood here? And B, C also important, but deeply need boundaries, definition, and things. Level curve, scale. Sketch is not important, but find level curve. Again, a level curve. Level surface, kaka. Clear exercises? Was like that. Sometimes some of the exercises need what? Computer exploring, and use the computer program to find something like that. Clear, dears?